Hi there, Ms. Barber here. I'm providing for you some worked exercises of problems similar to some of the problems of your homework assignment. Example, consider an 8-bit string. Bit is short for binary digit. Thus, a bit string is a string of binary digits or simply a series of zeros and ones. With that, we get that an 8-bit string is a series of 8 zeros and ones and can be in any combination or order. Each position of a bit string is a two-value choice. That is, it's either 0 or 1. The selection is equally likely, and the value of each position is independent. This problem allows us to use Pascal's triangle, so let's consider a representation of Pascal's triangle. With an 8-bit string, we reference the 8th row of the triangle. That consists of the numbers 1, 8, 28, 56, 70, 56, 28, 8, and 1. The number of each cell of the row represents the number of ways an event can occur. The position describes the event that is occurring. So, we'll choose to start with the left-hand side representing the number of ways a 1 is selected. Then the 1 tells us that there is only one way in which all 8 digits of this bit string is 1. Let's repeat that. There is only one way to have all ones. Now consider the number 8. That is to the immediate right of the 1. The 8 is the number of ways to have 7 ones and 1 0. Continuing, the number to the right of 8 is 28. The binomial expansion, as represented by Pascal's triangle, tells us that there are 28 ways to have 6 ones and 2 zeros. Let me repeat that again. There are 28 ways to have 6 ones and 2 zeros. So, let's answer part A. How many have 6 ones? From Pascal's triangle, so we'll write from Pascal's triangle, we find out that the number is 28. Okay. We can also compute this directly as 8, choose 6. Part B, how many have more than 6 ones? To have more than 6 ones means you either have 7 or 8 ones. Again, we reference Pascal's triangle, and to have either 8 or 7 ones, it tells us there's only one way to have a total of all ones, and there are 8 ways to have exactly 7 ones. So, by Pascal's triangle, we need to attribute where we're getting the answers. By Pascal's triangle, okay, we get that there is one way to get all ones and 8 ways to get 7 ones, and so that total is 9. This can also be computed directly as a combination of 8, choose 8, so if the 8-digit places, choose all 8 to be ones, and add that to 8, choose 7 of the 8-bit string places, choose 7 of them to be 1, and this is also equal to 9. Part C, how many end with 3 numbers that are all the same? So we still have an 8-bit string, and the first 5 could be 0 or 1. So we can have 0 or 1, 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 and 0, 0, 0, or 0 or 1, 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 and 1, 1, 1. Let's note that for the first 5 digits, there's 2 to the 5 different ways in which you can have this arrangement. There is only one way to get 0, 0, 0 for the last 3 digits. or means plus. And so, again, for the first 5 digits, there's 2 to the 5 ways in which you could do the 0 or combination, but there is only one way in which you can get 1, 1, 1. So this actually becomes 2 of 2 to the 5th, because you have 1 2 to the 5th for this one and another one. This becomes 2 to the 6th using rules of exponents, and 2 to the 6th is 64.